The usual fuel in modern turbine engines is kerosene-type jet fuel. The engine-driven fuel pump is normally a high-pressure positive displacement pump. A clogged fuel filter indicated by rising differential pressure may require filter bypass to maintain fuel flow. Fuel heating in turbine engines is primarily to prevent icing and wax formation. FADAC fuel control systems primarily provide digital control of fuel and engine parameters. The main purpose of the lubrication system is to lubricate and cool bearings and gears. An oil tank, the aerator, is used to remove air bubbles from returning oil. Oil system filters are often fitted with bypass valves to allow some unfiltered oil to flow if filter is blocked. Low oil pressure and high oil temperature in flight may indicate oil system blockage or loss. Bearing sumps are sealed mainly to prevent oil from entering gas path. Engine bleed air is commonly used for anti-icing, pressurization, and air conditioning. Anti-ice bleed air is taken from intermediate or high-pressure compressor stages to provide sufficiently hot air to prevent icing. Using bleed air for aircraft systems generally reduces available engine thrust. Cooling air for turbine discs and blades is usually supplied from compressor stages. A significant bleed air leak may be indicated by unusual temperature rise in nacelle or warning from sensors. A typical air turbine starter is driven by bleed air or external air source. During engine start, the parameter that should rise first after light up is EGT, ITT. A hot start is characterized by excessive AGT rise for a given RPM. A hung start occurs when RPM stops increasing before reaching idle. AGT may be high. If no light up occurs during start, the first action is normally to shut off fuel and motor the engine. Ignition is normally selected on before introducing fuel, and off after stable idle. Continuous ignition may be selected during takeoff, landing, heavy rain, or turbulence. Typical gas turbine ignition plugs are surface gap or air gap spark igniters. The ignition exciter unit converts DC or AC to high voltage pulses. In many turbofans, takeoff thrust is set using EPR or N1 indications. EPR is defined as exhaust pressure divided by inlet pressure. A vibration increase on the engine instrument may indicate fan, compressor, turbine imbalance or damage. Engine trend monitoring is used to detect gradual engine performance deterioration. Parameters commonly recorded for engine trend analysis include EGT, N1, N2, fuel flow, and oil parameters. An auxiliary power unit, APU, mainly provides electrical power and bleed air on ground and sometimes in flight.